The first problem we're going to work on here involves a couple pairs of overlapping triangles that we're trying to prove congruent. We're trying to prove why triangle FHJ is congruent to triangle KHG. We can see that they overlap and they share angle H right here. So we know angle H could be said as congruent to itself. We already see that they have a couple pairs of congruent angles there. So we have at least two pairs of angles that are pretty easy to see. But then the other part that would be congruent between them is a little bit more difficult to see. If I look at this picture, I see that segment FL is congruent to segment KL, and segment LG is congruent to segment LJ. But the problem is those segments don't by themselves make up sides of my two triangles that I want to say are congruent, right? They don't make up sides that are congruent for triangle FGH or FJH. But we can kind of use a little bit of common sense, or maybe we can put some hypothetical measurements on here. We can say, well, maybe that's 4 and that's 4, and maybe this is 3 and this is 3. And if that's the case, then FJ would have a distance of 7, or a length of 7, because 4 plus 3 would be 7. And KG would have a length of 7, because 4 plus 3 would also be 7. And so it's clear that FG and FJ are the same length. But we need to figure out how we're going to kind of write that in an explanation. And so here's what I'm going to do. Well, first I'm going to list out the parts that we've already kind of identified are pretty clearly congruent. I'm going to say that angle F is congruent to angle K. That is given. And just as a note, I'm going to just put a note that's a pair of angles. And I'm going to say that angle H is congruent to angle H by the reflexive property. It's the angle that both triangles share. Now I need to get through the explanation for why FJ must be the same length as KG. Here's how I'm going to do it. I'm going to say that FJ is equal to FL plus LJ. And I'm also going to say along the same lines that KG is equal to KL plus LG. And the reason both of these things are true is the segment addition postulate. Talked briefly about that in the notes video for this section, the segment addition postulate. But then if I look at some given information, I can see that this FL and this KL are equal to each other. The FL is equal to the KL, and also this LJ is equal to this LG, right? L to J, L to G, those are the same length. That's given information. They're marked congruent, so we can say that their lengths are the same. This is the part that's a little bit tricky. What I'm going to now do is I'm going to take this statement right here. I'm going to take this statement. I'm going to rewrite that statement, but I'm going to change the FL into KL, which is a legal move because they're equal, they're equivalent to each other. So I'm going to say FJ is now equal to KL, and I'm also going to change the LJ into an LG. So instead of FL plus LJ, it's going to say KL plus LG. And the reason I'm allowed to do that is by the substitution property, which says that anytime two things are equal to each other, they can be substituted for one another in a statement, in like an equation. But then I notice, hey, look, this and this, they kind of have something in common, right? They have this KL plus LG part. So I could take this statement now, KG equals KL plus LG. I could write KG equals, but instead of writing the KL plus LG part, I can come down here and I say, well, let me just replace that. Right? Let me just take this part of it and replace it with FJ. So instead of writing KG equals KL plus LG, I'll replace it with FJ. And now I've essentially said that KG is congruent to FJ, segment KG is congruent to segment FJ, which is my pair of sides that I now need to be able to say that triangle FHJ is congruent to triangle FHG by, it looks to me like that would be angle, angle, and a non-included side, angle, angle, and a non-included side. So we're going to say by angle, angle, side. So in this second example, we're going to be looking at something similar where we have a couple triangles that we want to prove congruent. Triangle SRV. I'm just going to kind of highlight those right here. Triangle SRV. We want to prove congruent to triangle TUW right here. And I noticed that right away those two triangles have a couple pairs of parts congruent. SR congruent to TU, and they're both right triangles, so they have these angles congruent, but they're right angles. So one of the things that would be available to me is by using HL if I could prove that segment SV and segment TW are congruent. All right, I'm going to get rid of some of this highlighting. It's kind of distracting me a little bit, so let me just get rid of this highlighting here a little. Okay, so now if I could prove that for some reason segment SV is congruent to segment TW, then I would have HL congruence for the two triangles I'm trying to prove congruent. Then I might notice, well, TW and SV, they're parts of a couple other pairs of triangles in this picture. Triangle WST and triangle VTS. Use those parts as corresponding parts. And I see that this angle and this angle are congruent, that this angle and this angle are congruent, and that those two triangles share segment TS. So I think I can prove that those two triangles are congruent. Then I can use CPCTC to say that segment SV is congruent to segment TW, which would let me say that these two triangles, SRV and TUW, are congruent by HL. So I'm going to, just to kind of outline my game plan here, I'm going to say that triangle VST is congruent to triangle WTS by, it looks to me like that's angle, angle, side, since they share segment ST and they already have a couple pairs of angles marked. Then I'm going to say that means that segment SV is congruent to segment TW by CPCTC, which will let me finally say that triangle SRV is congruent to triangle TUW by HL. But I got some information to fill in. But this is kind of like my outline. This is my general game plan for what I'm going to do. So let's go ahead and take a look at how we're going to fill in some of the details about why these things are true. First, I'm going to say that angle SWT is congruent to angle TVS. That's given. All right, that's these two angles here. And that angle WTS is congruent to angle VST, which is also given. And that segment ST is congruent to segment TS by the reflexive property. That's all my evidence for why these two triangles are congruent by angle, angle, side. So next I'll say that triangle VST is congruent to triangle WTS by angle, angle, side. Then I'm going to switch over and I'm going to say, alright, if those two triangles are congruent, segment SV must be congruent to segment TW by CPCTC. So now I've decided that this segment and this segment are congruent, segment SV and segment TW. I also have segment SR congruent to segment TU, that's given, and triangle SRV and triangle TUW are right triangles. It's given. It shows me that they have right angles in them. And since this is the hypotenuse for those two right triangles, and this is a leg for those right triangles, then finally I can say that triangle SRV is congruent to triangle TUW by HL.